So far, when we've been talking about proportionality, we've been talking about um, constant proportionality or um, proportionality in tables and how we can find the constant and proportionality from a table or see if a set of values in a table is proportional. But now we're going to see the special principle or properties of proportionality in graphs. So, if we scroll down a little bit, it says use the information below to create a table and determine the constant of proportionality k. A bike rider cycles 18 miles in 1 hour. So if you look here, we have a column of hours and a column of miles. Remember, our first one is our x value, the second one is a y. And notice we can't just plug in the values in order because this is hours. So in 1 hour, the cyclist will, or bike rider will travel 18 miles. Notice there's nothing else given here, but because we know that they're traveling 18 miles every hour, we could just double it. What if they went 2 hours? They would travel 36 miles. 3 hours, 54 miles. 4 hours. How am I getting this? Remember, I am just timesing the number of hours by 18. Because if they're going 18 miles in 1 hour, if you double 1 to go 2 hours, you're going to double 18. If you triple 1 to get 3 hours, you're going to triple 18. So I'm just going to keep it simple and go 5 times 18 and 6 times 18 and 7 times 18. But what we can do, because remember, we said that there's an x value and y value, we can write ordered pairs out of these. So in this one, our x value is 1, our y value is 18. And then we put parentheses around them. We have 2, 36, 3, 54, sorry if this is getting sloppy, 4, 72, 5 and 90, 6 and 108, and 7 and 126. Okay, so we have a table which we can really basically use to find our k. Now remember, a lot of times we find k by going y divided by x, but our constant of proportionality is a number we're multiplying by. So if you think of it like this, we could go 18 divided by 1, which is 18, 36 divided by 2, which is 18, or you could just think, what am I multiplying by every single time? Any way you look at it, your k, your constant of proportionality, is 18. Now remember, we have to write an equation. Don't overthink the equation. We have y equals whatever k is times x. K is 18, so we plug that in. Y equals, instead of k, we say 18x. Let's see if I write a little bit neater. And I know that equation can be confusing because it seems like we're doing the same thing twice. But what we're basically doing is we are just plugging in a number for our constant because that's the number we're multiplying by. And in this case, we're multiplying by 18 every single time. Now, we can use these ordered pairs to graph it. So we have, I'll put our x values is the hours. And our y values are the total miles. And I'm trying to write sideways here, so don't laugh too hard. Yeah, it's not awful. And now we need to pick a scale. Well, I look at my hours here and I'm going through 1 through 7. So I'm going to start, the first line here is 1, 2, 3, 4, 5, 6, 7, and 8 there. Now going on our Y column, you really could pick a whole bunch of different things. You go by tens, by fives, by twos, and this is going to seem weird, but honestly, we're going up by 18 every single time. So I'm actually going to go by 18s. 18, 36. Please do not think that we put these numbers on the lines every single time, because that is not true. But in this case, I know we're adding 18 every single time, so I'm just going to use that. And use it to my advantage. And then I'm going to plot the points. I have the point 118. So 1 on the x is the x value, 18 is the y. And I have 236, 354. Ooh, that was bad. 4, I know it doesn't look like a 4, but it is. 472, 590, 6108, 7126. Now, you can draw a straight line through those. So let's talk about this line, okay? Notice that every time we go up, we're going up 1 over 18, up 1 over 18, up 1 over 18. And since we're increasing by the same amount every time, that makes this line straight because it has a constant. And notice also where it's hitting. That's going to become important too. So let's look now at some characteristics of graphs. Now, notice we have the graphs here. These two are proportional, these two are non-proportional. So let's think of some characteristics. Well, looking at these two graphs here, the first thing I notice is they're both straight lines. This one's going up, this one's going down, but they're both straight. The other thing I notice is where they're intersecting the x-axis. Both of them pass through the origin. Which is 0, 0. Now let's compare that to these two graphs here, which are non-proportional. Now, well, this one's a straight line, but this one isn't. So we could say both are not straight lines. And, well, you know what? If we're going to focus on the first one, that origin, they don't pass through the origin. And those two things, being straight lines and passing through the origin, are going to be ways to tell if a graph is proportional or not.